Welcome back. This is day 10 of our solving quadratics unit. Today we'll be solving vertical motion problems. We will be using the methods that we have learned so far for solving quadratics. This includes factoring, taking square roots, and the quadratic formula. This lesson is really important because we will have a project based on this concept at the end of the next unit. Just a reminder, a copy of the handout is provided in the description so you can follow along. Enjoy. Oh yeah, our do now problem is a which one doesn't belong. I love these. Your job is to find a reason for why each problem A, B, C, D is different from the others. There could be many different answers for each one. So pause the video, take a few minutes to find a reason why each problem doesn't belong, and then resume the video when finished. With this one, which one doesn't belong. So it looks like this is my great artwork right here, but it looks like we're taking a ball and we're gonna throw it. Um, I I think I don't even have anything for A. I mean, I wish I would have had something for A, but I don't even have why A doesn't belong. B, I can say it looks like in B they're just throwing a ball straight down, or they're dropping a ball. I can't tell if they're throwing it or dropping it, but um, C is different than the rest because it's the only one where the person's standing on the ground. So if you look at A and B, they are on some kind of platform. So we have some kind of platform here. So these two are standing on something and they're throwing the ball. But C is the only one where he's standing on the ground. Okay? So today we're going to be studying vertical motions, and it's basically this whole idea, what's going on here. And what you should notice, I should have drawn this one to go like, the ball goes like this. But anyways, what we're going to be studying today is the ball going only throwing the ball straight up and down, or straight up or straight down. All right. Our notes for today. Notes. Looks like we got a little vocab word. So we got velocity. So velocity is the speed. So how fast something is going in a given direction. All right. So I guess velocity is speed, but it has to be going in a certain direction. And today in this lesson, we're only going to be studying things that go up and things that go down. Okay, so nothing that's going sideways or anything like that. All right, modeling projectile objects. So a dropped object can be modeled with this formula. So if we're dropping something, a dropped object can be modeled with this formula. So it looks like here's the little formula. All right, so let's see what all these letters stand for. So we have some variables here. So the first thing, h represents the height of the object in feet. So here's h, and that will always tell us the height of an object in feet. All right, not too bad. H sub 0, so this little guy here, represents the initial height. So the initial height of an object in feet also. So this little guy here is the initial height. And now if you think back to the last two problems, let me go back over here. So when we say initial height, we saw that these people were standing on some platforms. So when we say initial height, we mean this guy right here. This is the initial height. So you see how the ball is off the ground. And over here, it's wherever we're releasing this ball from. So this is my initial height. And over here, it's much smaller because we're not standing on a platform. So that's my initial height. All right, perfect. And t represents the time. So t is just the time of object, and we're measuring in seconds. So when you see these variables in here, when you see t, that's just your time. Okay, so we got time, and we have your height of your object, and then this over here is your initial height. Okay, not too bad. And so that's all of this is when we just drop an object. So if you grab like a pencil and you just drop it, this is the formula that we're going to use. This is the function we're going to use. All right, let's try the other one. Let's look at the other one. So what happens if we throw an object? So now thrown objects can be modeled with this formula here. Now, if we just use what we learned from the previous one, we should know that h is going to be what again? That's the height of the object. Okay. Anything else look familiar? Yeah, I see t. T is, we have two places for t this time. So we have t here and we have t here, and that's just going to stand for your time. And last we have this over here is my initial height again. Perfect. Okay, and so the only thing different now, we have one more thing. We have v sub 0 represents the initial velocity. So initial velocity. So now we're talking, and it's in, ooh, I have a little typo here. It's in feet per second. Okay, so make sure you have this in there, feet per second. So now this little variable right here is my, let's draw it out here. That's my initial velocity. Okay, so that's the only thing different. So when you look at these two, how come we're missing this little green part here, the initial velocity in the dropped object? Well, obviously, if you drop an object, you're not like providing any speed to it, you're just letting go of it. But this other one, the initial velocity, means we're going to throw it. We're actually going to put speed into it, we're going to put some effort into it, and we're going to throw it down, or we're going to throw it up. All right, so that's what we're talking about. All right, so now let's see if we can use this to solve some problems. And what you should notice is that these are all quadratic. So again, this is going back to Intuit. This is why it's in our quadratic unit, because we're going to be solving these quadratic equations pretty soon. Let's try problem number one. Problem number one, a juggler tosses a ball into the air. The ball leaves the juggler's hand 4 feet above the ground and has an initial velocity of 60 feet per second. All right, perfect. So this is about a juggler just throwing a ball in the air. Let's do part A first, sketch a picture. Well, I could sketch a picture. That's not going to be too bad. Let me go to the next page, though, so that way I have more room when I start solving. So let's sketch a picture. So here we go. This is going to be, and again, I'm not a great artist, but I will make my juggler. He's going to throw a ball. And it's going to go up in the air, and then eventually it'll come back down. Okay, so there's my juggler. So let's try part B. What is the height of the ball after 3 seconds? I'm going to go back and I'm going to label this picture up, because right now I need to start actually putting in some information here. A juggler tosses a ball into the air. The ball leaves the juggler's hand 4 feet above the ground. So what is this? This right here is your initial height. Initial height. That's where we're throwing the ball from. So I'm going to label that right here. So my initial height is going to be 4 feet. And remember, initial height, we call it 8 sub 0. So that's going to be 4 feet. All right. What else did we know in this problem? We also knew in this problem it has an initial velocity of 60 feet per second. So velocity, that's a speed, 60 feet per second. So I'm just going to label it on the picture. So this is 60 feet per second. Now, we said that initial velocity, we label that with v sub 0. And that's going to be 60 feet per second. Okay, perfect. So now we have a beautiful diagram, and we've labeled it, and it looks nice. So now let's try to solve this problem. What's the question? What is the height of the ball after t seconds? So we want to know what is the height of the ball after t seconds. T is in seconds, and that's going to be 3. Okay, so what is the height of the ball after 3 seconds? Now, we know there's a formula that we started working with. Let me write that formula out. So if we're throwing the ball with a velocity, we'll have to use the second formula. So that's going to be h is equal to negative 16 t squared plus our initial velocity times t plus our initial height. So there's our formula. Now, let's substitute all the things that we know. So we know three things. We know the initial height, we know the initial velocity, and we know we want to know when the ball is 3 seconds in the air. So we know three different values here. So let's see if we can do this. So h is equal to -16. And for t, what are we going to use for t? We're going to use the 3 seconds. So we'll put in 3 seconds plus, and our initial velocity now, what are we going to use for initial velocity? We're going to use 60. And there's t. Ooh, but I'm not going to use t. Let me rewind that. We're going to use, what was t? T is going to be 3 seconds. That's what we're trying to figure out. And then we're going to add in our h sub 0 as our initial height. So we're going to add in 4. So plus 4. And there we go. So this is not too bad of a math problem. This looks like this is very doable. So let's see if we can finish this problem. So my height, my height is equal to, well, let's work this out. This is just a basic evaluate expression, like please excuse my different PEMDAS, order of operations. So -16 times 9, because 3 times 3 is 9, plus 60 times 3, that's 180, plus 4. So h is equal to, what's 16 times 9? 16 times 9 is -144 plus, and I'm going to add those up, so that's 184. And so my total is 40. Now, that's great. What does the h stand for? H is 40. So what does that tell us? The height of the ball after 3 seconds is 40 feet. Perfect, done. This is the problem. So, if we throw the ball from a height of 4 feet and at a velocity of 60 feet per second, so 1 second, 1 1,000, 2 1,000, 3 1,000, this ball will get to a height of 40 feet. So it'll be 40 feet in the air. Now you might be asking, like, how come it doesn't go 180 feet? Like, how come it's not 184? Because if you're 60 feet per second, every second it should travel 60 feet. What is holding it back? Why is it not going like so much higher? Why is it only going 40 feet? Well, obviously gravity is going to be pushing down on this too. So this formula is already figured out for gravity going to be pushing down on the ball. So you're going to throw it up, but gravity is going to push it back down to the earth. All right, so that's how we do this problem. Not too bad. Let's try problem B. Okay, part C. Let's go over this one. Let's see if we can figure this out. At what time is the ball 50 feet in the air? So what we're looking for right now is we want to know what is the time when the ball is in the air, so it has a height of 50 feet. Perfect. All right, so based on this, what else do we know? We still know from the last problem, we still know that the initial height was 4 feet. We know our velocity is 60 feet. So I think that's enough to start getting into this problem. Let's see if we can start working this out. So here we go. So h is equal to, again, I always write my formulas down. That helps me memorize them. Plus my initial velocity times t plus my initial height. And so this time we we want to know when the ball is at 50 feet. So when the height is 50 feet. So that means this time I'm going to use 50 feet for my height. -16 times t, but what is t going to be this time? Oh, t is just going to be t. We're not solving for that. I mean, we're going to be solving for that actually. So t squared, let me just rewrite that. I don't need all that. I thought I was substituting. So t squared plus my initial velocity. What is my initial velocity? Still the same, 60 feet per second. And my initial height plus my initial height plus, and that was 4 feet. Okay. So now we're sitting here looking at this equation. And now what I see is it's not as easy as last time. Now I have a quadratic equation that I have to solve. Now, how would you solve a quadratic equation? So, well, you have a lot of methods to solve it. You can either factor. Before I even do that, I should make this all equal to 0. So let's subtract 50 from both sides. So this will be equal to negative 16 t squared plus 60t. And then if I subtracted 50 from both sides, this should be negative 46. Perfect. So there's my quadratic equation. I am going to need some more space. I know that already. So let me just slide this down. All right. Now, how do you solve these type of equations? Well, you can try factoring. I don't think this is going to... I don't even want to try factoring. I can complete the square. And that might be pretty quick. But the numbers are large, and this is where I would just use a quadratic formula. So let's solve this. So t is equal to, I would just use the quadratic formula. This is going to be the easiest when I have large numbers, when the numbers are going to be not friendly to work with, especially decimals and fractions. I would just use this formula, and this will be a lot easier. So let's take whatever b is, what a is, what c is. So remember, here's A, here's B, and here's C. So A, B, and C. So we're going to use those values, substitute in there, and then we're going to let the calculator do the work for us. All right, so T is equal to the opposite of B. The opposite of positive 60 is just going to be negative 60, plus or minus the square root. So that's 60 squared. Subtract 4 times A times C. And A in this problem is negative 16. And B in this problem is negative 46. Perfect. All of this divided by 2 times A. All of that divided by 2 times A. So we're going to divide by, again, look at these numbers are large. So again, I like this formula, especially when I'm doing this kind of work right here. So let's see what I got here. So T is equal to negative 60. Let's simplify a little bit. Plus or minus 60 squared is just 3,600. Negative 4 times negative 16 times negative 46 is going to be calculator work. Negative 2,944. And all of this divided by negative 32. Perfect. All right, let's continue on a little bit more. All right, let's continue simplifying. So this will just be t is equal to negative 60 plus or minus the square root of, what is that? More calculator work. 656, all divided by negative 32. And then from here, I would just use Desmos. So I'm going to show you how to use Desmos right now, just to calculate that. I wouldn't simplify that. I would just leave it alone right now, and let's figure out what our answers are. Okay. Desmos, the calculator part. So again, you can just type in this little section over here and you can use the calculator. So this will just be my equations. So we were typing in negative 60. Let me open the little launch pad there. So negative 60, let's see if that'll work. Yes, negative 60 plus or minus. So now remember, the plus or minus is a positive answer and a negative one. So I'm going to put a plus for the first one and we wanted the square root, so here's the square root symbol, and then we wanted 656. And let me see, how do I make this a fraction? Let's see. Oh, you know what I should do? I should put this in parentheses. So I'll put that in parentheses because I want to divide all of that. So divide, hit the division. There we go. Divide by -32. Perfect. And there's my answer. All right, so I found the first one. So I found my first answer. And the next answer, I want the same thing. So let's plug that in. So -60. But this time I want the minus. Remember, it's a plus and a minus, so I'm going to subtract this time. Plus and minus. And the square root, 656. And I want all of that divided by... Whoa. Something happened. Back. That one. Okay, 656. Let me make sure I'm outside of that. There we go. Okay, that'll work. Let's get rid of that. That's bugging me. All right, so all of that divided by -32. Perfect. And there's your two answers. All right, so you're going to use both those two answers, and that's how we solve the problem. Now that we use decimals, we know our answers. So we have two answers. So we have t is equal to, I'm going to round to the nearest hundredth, 1.07 seconds. And then we have another answer, or t is equal to 2.67, I should round that, sorry, 2.68 seconds. Okay, perfect. So what that tells us, let's write our answer. So the ball will be at a height, height of 50 feet at 1.07 seconds and 2.68 seconds. And we're done. Okay, but before we finish, I want to show you and take you another layer. Next chapter we get into all graphing, but I'm going to graph this right now and kind of show you to show you that this makes sense. Number 2, a rocket is shot from a 50-foot platform. The rocket has an initial velocity of 350 feet per second. Part A, sketch a picture. All right, let's do a picture. So I have some kind of platform, and this platform they said was 50 feet. So I'll write that in. So this is 50 feet. And there's a rocket that sits on top. So I'm going to set a rocket on here. There's my rocket. It's just like a triangle, little boosters. Okay, so there's my rocket. And oh, the initial velocity. So this thing is gonna shoot up like that at 350 feet per second. So that's how fast it's gonna shoot up in the air. All right, so what do we know in this problem? We know that, let's just write this down. We know that my initial height of the rocket is 50 feet. And we also know that the initial velocity is 350 feet per second. Okay, perfect. So, question part B. What is the height of the rocket after 10 seconds? So, when we count to 10, 1, 1,000, 2, 1,000, how high in the air will the rocket be? Well, let's just go ahead and use our formula that we learned today. And let's figure this out. So h equals -16 t squared plus our initial velocity times time. And then we're going to add in our initial height. All right. So what are we looking for in this problem? We want to know the height of an object, so we want to know what is the height after when time is 10 seconds. So when time is 10 seconds, after 10 seconds, what is the height of this object? So let's start working this out. So h is equal to negative 16, and then t is time, so we're going to plug in our 10, we're going to substitute our 10 in there, plus our initial velocity. What was the initial velocity? Our initial velocity was 350 feet per second, and then times the time, which was 10 seconds. Perfect. And then plus, and what is our initial height? Well, the rocket was 50 feet off the ground, so that's plus 50. So there's our math problem. And this is just a nice and easy little work it out problem, and we should be done here. So we're going to go with h is equal to negative 16. What's 10 squared? What's 10 times 10? That's just 100. Now 350 times 10, which is just 3,500 plus 50. Okay, not too bad. And then we're going to go h is equal to negative 1,600 plus 3,500 plus 50. And our final answer is 1950. So what does that tell us? That tells us, let's write this in, after 10 seconds, the height of the rocket is, what is it? 1,950 feet. Bam. Perfect. So after 10 seconds, the height of the rocket will be 1,950 feet. All right, part B, that wasn't too bad. Problem C is going to take a little bit longer, so let's go over that one. Okay, now what about problem C? Let's do that one. How long is the rocket in the air? All right, so let's see what we got here. So how long is the rocket in the air? So that means that we want to know t is 0. Our t is what we're looking for, time. How long is the rocket in the air? That means that's a time question. Also, we need to know if I'm really trying to figure out how long the rocket's in the air, what I'm really asking is, when did it hit the ground? Does that make sense? It's in the air until it hits the ground. So that means that our height is going to be 0. So we want to know how long it's in the air until it hits the ground. And we already know what? We already know two things. We know our initial height, so we already know what that is. That's right there, it's 50. And we know our initial velocity. So my initial velocity is 350 feet per second. So we already have those written down. So we're going to use those, and then we're going to see what we can do here. We're going to solve this problem. So again, let's start with my formula, negative 16 t squared minus, plus the initial velocity times t plus the initial height. All right, so there's my formula. Let's use all our values that we know. So this time we know the height of an object. We want to know it's 0 because, dismiss. Okay, we want to know the height of the object is 0 because we want to know when it hits the ground. Negative 16t, we're not going to know what t is, so we're going to leave that alone. Plus our initial velocity. We do know the initial velocity, which is 350 times t, and then plus my initial height. So then we're going to add in my initial height, which is 50. Okay, so there's your problem. So you're looking at that problem, and what should you be thinking? You should be thinking, how am I going to solve that? Now, if you want, you can try factoring. I don't know if I wouldn't even try that. Completing the square may be another good way to try. I don't want to do that. When I see numbers like 350 in here and negative 16, I'm thinking I'm just going to use my quadratic formula. So let's use that. So we're going to say, let's solve this. So t is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a, all divided by 2a. Okay? And now remember what A, B, and C are. Let me just circle those. A is going to be the negative 16, that's A. B is the positive 350, that's B. C is the positive 50. So there's A, B, and C. So use those, and then it's just calculator work for this problem. So this one is T is equal to, the opposite of 350 is negative 350. Plus or minus the square root, B squared, well, that's going to be 350 squared. Minus 4 times A, which is negative 16, times C, which is 50. All of this divided by 2 times, what is A in this problem? Negative 16. So that's it. I just did one huge substitution, and then I'll just work this out. So let's try to work this out quickly. So T is equal to negative 350 plus or minus the square root. And my calculator, 350 squared is 122,500. And then we are going to multiply this together. What's negative 4 times negative 16 times 50? That's going to be 3,200. All of this divided by negative 32. All right, now we'll just keep simplifying, and we're going to get T is equal to negative 350 plus or minus the square root of 125,700, all divided by negative 32. So I would leave it right here, because now this is just calculator work. So we should go into Desmos or something else to find out what the answer is for this problem. Okay, so I've graphed our parabola here. So you can see the equation is negative 16x squared plus 350. 350 is the initial velocity plus the 50, and that is our initial height. So now let's find our answers. So the answers for this problem, it looks like it's going to be negative 350. Remember, plus and minus, we're going to have to do them separately. So plus or minus the square root of 125,700. Okay, and we're going to take that value and we're going to divide by negative 32. Whoa, 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 whoa. Delete this. Let me get outside that parenthesis. Close it off. Okay, perfect. Let me just delete this first parenthesis right here, so it looks nicely. Okay, perfect. And now divide by negative 32. Okay, so there's my first answer. So my first answer is negative, what is that, 1400ths of a second? And we'll talk about that in a second. So now let's do the same thing, but now let's do one with the positive answer. So we'll go negative 350, subtract the square root 125,700. Let's close out of that. And we're going to divide everything by negative 32. Perfect. And there's my two answers. All right, let me hide this keyboard for a little bit. So now I want to show you on the graph. Remember, this graph right here is the time in seconds versus the height of the object. Now, when does it hit the ground? When it hits the ground, when the height is 0. So that's going to be at two places. Let me just see if I can zoom in here. See if I can get it. So I have two places. There's one place, and here's the other one. And what do we notice? Those are our two answers that we had from our quadratic formula. So now, in this problem, which one of these makes sense? The ball's not going to hit the ground twice, but which one's going to make sense? Well, it makes sense, the one where it says the 22 seconds. All right, the negative's not going to make sense in this problem. That is an answer based on the graph, but the answer that makes sense in this problem is 22 seconds. So around 22 seconds. All right. Problem number 3. All right, let's do this one. If you drop a ball from 25 feet in the air, how long will it take till the ball hits the ground? Let's sketch a picture. So we are on some platform again. Maybe we're on the building, we're on the roof of your house. There we go. And you're going to be standing up here. Perfect. And you have some ball. And here's the ball. And we are going to drop it. So we're going to drop this ball. And it's going to go bang and hit the ground right here. All right. What do we know right now? We know the height of this ball is 25 feet in the air. Perfect. Okay. Now, let's record some things. So that tells me my height, my initial height is going to be 25 feet. Now, my question is, what's the initial velocity? What is the initial velocity for this problem? If you just go on top of the roof and you drop the ball, is there any velocity in this problem? No, the initial velocity in this problem should be 0. All right, so my initial velocity is going to be 0 because we're not doing anything. We're just letting go of the ball. All right, now that's interesting because now that's going to make our problem it's actually make our problem a little bit easier. So what is the question asking us? If you drop a ball from 25 feet in the air, how long will it take to hit the ground? So hitting the ground, again, remember like last problem, is going to be when your height is equal to 0, because that's when it's going to hit the ground. And how long is the time? So that means the time is what we're looking for. So we need to find time. So there's our problem. Let's see what we know so far. We know our initial height is 25 feet. That's how high the ball is off the ground. We are not throwing it up in the air or throwing it downwards, so we're just letting go of it. So your initial velocity is going to be 0. My height, what we're trying to figure out is when the ball hits the ground. So that means the height will be 0, and the time is what we're going to figure out. So let's solve this problem. This one shouldn't be too bad. H is equal to negative 16 t squared minus my initial velocity. My initial velocity this time is 0, so this is 0 times t. And my initial height is 25, so we're going to add 25. Perfect. There we go. You know what? I don't know why I did this. I should have wrote down the formula first. Negative 16 t squared subtract my initial velocity times t. Why am I subtracting plus? H sub 0. So plus my initial height. Okay, so I should have wrote that formula down first. You guys need to get in that habit too. And I'm going to simplify this problem one time. So we're going to get H is equal to negative 16 t squared. I don't really need this middle term here because 0 times that's going to be 0, so we're going to get plus 25. And actually, we know what our height is over here, so the height is going to be 0 because that's what we're looking for. When does it hit the ground? So I'm just going to rewrite this again so it's nice and neat. So 0 is equal to negative 16 t squared plus 25. Okay, beautiful. So there's my problem. Now, because this problem is written like this, I can solve this problem 3 different ways. So I'm going to solve this problem 3 different ways. Because again, you should be good at solving a quadratic equation now, and you should have other ways you can do it. So let's solve this problem, but I'm going to go on to the next page and then solve this one. 3 different ways. Okay, let's solve this problem. So let's go with number 1. So first way of solving this problem. When I look at this, I only see t squared. That's my only variable. I don't have anything else. So I'm just going to solve this by isolating the t squared and then taking a square root at the end. So watch. So I'm going to take this. This is going to be 0 is equal to negative 16 t squared plus 25. So what I'm going to do is nice and easy. I'm just going to subtract 25 from both sides of my equation. And I'll get negative 25 is equal to negative 16 t squared. Then I'm going to divide both sides of my equation by negative 16. And that will give me 25 over 16 is equal to t squared. Look how simple this problem's getting. And then I will take a square root of both sides. So I'll take a square root of this side, and I'll have to do a plus and a minus. And that will leave me with plus or minus, what's the square root of 25? Well, that's just 5. What's the square root of 16, which is just 4? And so my answer for this problem is t equals plus or minus 5/4. Perfect. So now I'm going to solve it the other ways, and then we'll go over it and we'll put this answer in context. But that's one way of doing this problem. The second way of doing this problem, so if you were good at factoring, some of you might have noticed this and said, oh, negative 16t squared plus 25. So some of you might have said, this kind of looks like a difference of squares problem. I'm going to multiply real quick everything by -1, so that's going to change my answer. So this is I'm just going to multiply real quick by -1, so this will be still 0. This negative 16 will turn into a positive 16t squared, and the positive 25 will turn into a negative 25. So all I did was take everything and I just multiplied. I multiplied this side by -1, and I multiplied this side of my equation by -1. All right, now the reason I did that was because this is a perfect little difference of squares problem, and you can factor this problem right now. So how does this factor out to be? Well, you should remember this one. This is 4t plus 5 and a 4t minus 5. And we can use the zero product property. So zero product property says we can solve both equations, set them equal to 0, and solve these problems. So you can do that problem and this problem, minus 5 equals 0. And what are your two answers? So I'm going to skip a few steps, but I'm going to subtract 5 and divide by 4, so I'll get negative 5/4. Or my second problem is, on this one, t equals positive 5/4. And what do you notice? It's the same two answers that we got from our first problem. So again, as you start getting better at this, you have other ways you can solve these problems. And number 3, let's say we wanted to take the same problem equals negative 16t squared at 25. So let's say that was your problem. All right, you can also use the quadratic formula. Now this one's going to be a little bit longer, but again, this method always works. So x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. All right, perfect. Let's see if we can find out. Well, this is a. Is there a b term? There's no b term, so I'm not going to even write that one. So, and this is c. So we don't even have a b. B is going to be, I'm going to write down here, b is equal to 0. There's no b term. All right. So then we are going to write this as x equals, the opposite of 0 is just 0, plus or minus the square root of 0 squared, which is just 0, minus 4 times a, which is 16. I'm running out of room. 16 times 25. It's getting messy. Let me just write it underneath. I'm gonna skip this step and write it down a little bit lower so I have more room. So x is equal to 0 plus or minus the square root of 0 squared minus 4 times a, which is negative 16, times c, which is 25. All divided by 2 times a, which is 2 times negative 16. Okay, perfect. Let's continue to work this guy out. And x is equal to 0 plus or minus, what does that work out to be? That works out to be 1600 divided by negative 32. What's the square root of 1600? So I'm just going to get plus or minus. I don't even need the 0 anymore, so just plus or minus. What's the square root of 1600? That should be 40 over negative 32. So what you'll notice is that this works out to be, you have 40 over negative 32, and my other answer is 40 over, there's 32. But if you simplify this, divided by 8 on both sides, on numerator and denominator, you're going to get 5/4. So negative 5/4. Divide this one, you'll get positive 5/4. So what you should notice is that for each one of these problems, doesn't matter how you solved it, you could have used a quadratic formula. You could have tried to factor it using difference of squares, or you could have just solved for t squared by isolating the t squared and taking the square root. So again, you can solve this problem 3 different ways. But now let's go over what was the question. So how long does it take for the ball to hit the ground? So in this problem, from 25 feet in the air, if you drop this ball right here, it takes 5/4 of a second. What is 5/4 of a second? Or if you want to write it as, or 1.25, so a second and a quarter, 1.25 of a second, seconds to hit the ground. Okay, done. Easy. We don't need a negative answer, we only need the positive one. So here's the answer for problem number 3. Problem number 4. So again, when this problem has, this is the paragraph, I usually use a 3-read when I'm using these word prompts. So let's read first time to understand the problem. Ricardo is the quarterback for the football team. His coach wants to know how fast he throws. Ricardo throws a football straight in the air, and his coach records how long the ball was in the air. The ball was in the air for 8 seconds, and it was released from approximately 5 feet off the ground. How fast does Ricardo throw? Interesting. All right, so it seems that we can. What is this problem about? This problem is about Ricardo, the quarterback, throwing a ball. All right, so I'm not going to write that in because it's going to get messy. But so now I know what this problem's about. Number 2, read number 2. What is the question? So now I'm going to read it again and try to figure out what the question is, and I'll read the whole thing. So Ricardo is the quarterback for the football team. His coach wants to know how fast he throws. Ricardo throws the football straight in the air, and his coach records how long the ball was in the air. The ball was in the air approximately 8 seconds, and was released from approximately 5 feet off the ground. How fast does Ricardo throw? Well, it's pretty easy here. Question number 2. So read number 2. How fast does he throw? And again, the reason I like to write that question out is because when you're doing these word problems, you want to make sure that you know what you're trying to solve for. Like, sometimes you solve the problem and you're like, what was I doing anyways? Like, you did a lot of work, so you're confused on what you did. So again, it's really nice to write that out so you have it, so you can look it back and be like, did I answer the question? Especially if the question has more than one answer or more than one parts. All right, now this third read, I'm going to read and record all the important information. So Ricardo is the quarterback for the football team. That's not that important. That just gives us context. His coach wants to know how fast he throws. Okay, well, that's basically the question. Ricardo throws the ball straight in the air. So he's throwing the ball straight in the air. Now, that's big because we have a formula that we can do calculations when a ball is thrown straight up in the air. All right, so I'm going to write that down. So straight in air. Okay. And his coach records how long the ball was in the air. The ball was in the air for 8 seconds. So time equals 8 seconds. So we know time was 8 seconds until what? I'm just going to leave it like that. So the time is 8 seconds. Actually, I'm going to write in the air because that makes a difference. In the air. And it was approximately, so that's telling us our initial height. Our initial height is what? 5 feet. Perfect. So what do we look at? How fast does he throw? This should be a key for you guys right here. How fast does he throw? What are we really looking for? We want to know what the initial velocity is. That's what we're looking for. We want to figure out what is the initial velocity for this problem. and that'll tell us how fast he throws. That's what we're looking for. So let's go ahead and see if we can start using this equation to solve this problem. So h, because we're throwing the ball straight up in the air, we can use our projectile motion equation. So 16 t squared plus the initial velocity plus our initial height. Perfect. Now let's see what we do know. We're going to want to find our initial velocity, so that's going to be still there. We know when a ball is in the air for 8 seconds, there's something else we also know. What else do we know? We know the height at 8 seconds should be 0. So in 8 seconds, what is the height of the ball? It should be on the ground. So that means that at 8 seconds, the height should be 0. So when you're plugging this in, we should get a 0 because the ball's on the ground. And we are going to get negative 16. And the time, we already know the time is 8 seconds. We said that was 8 seconds squared plus my initial velocity, I don't know that, times, again, my time is 8 seconds, plus the initial height when the quarterback released the ball, about 5 feet. So there's my problem. So there's only one variable in this problem, and that's the v sub 0. So again, that means I can solve this. So this will be 0 is equal to negative 16 times 8 squared. What's 8 squared? That's 64. Plus, I'm going to rewrite this the other way around, 8 v sub 0 plus 5. Now I'm going to use a calculator. So this will give me 16 times 8, or 64, is going to be negative 1024 plus 8 v sub 0 plus 5. Combining like terms, we are going to get negative 1019 plus 8 sub 0, 8 times v sub 0. And let's just solve this equation, algebra 1 stuff right here. And I'll divide both sides by 8. And so we'll get 1019 divided by 8 equals v sub 0, which is approximately, in my calculator, 127.38 feet per second. That's how fast he throws. All right, perfect. So now, most of you are like, well, how fast is I? I don't measure anything in feet per second. All right, so we're going to have Google help us out real quick. Okay, so we're going to have Google help us out with this one, but that's the answer for this problem. So as you can see, what I did was I just did a little Google search on Google feet per second to miles per hour. Because again, when we're talking about throwing things and we want to know speed, most of the time we want to know miles per hour because that's how everything's measured. All right, so now let's see. Our answer for this problem was 127.38 or 38 hundredths feet per second. And look what you already see. What do I see right now? That it says that is equivalent to 86.85 miles per hour. So what can we tell now about the quarterback? We should know that the quarterback throws 86, about 86 miles per hour. So this is equivalent to, so this is approximately, according to Google, approximately, I'll just write it here. So Ricardo throws about 86 miles per hour. That's pretty good. I wonder what the professionals throw. I have to look that up. All right. But now, what I really want you to understand from this problem was this kind of gives us a little insight. So we knew two things. Ricardo went outside, he threw a ball in the air, and he also knew the initial height that he let go of the ball. But using those two things, we can figure out the initial velocity of the throw. Now, this is important because later on you're going to have a project where you're going to do this exact same thing. So if you wanted to figure out how fast you throw, you can go outside, get a ball, throw it straight in the air, time it, and using how long it's in the air and wherever you let go of that ball at, you can figure out what your initial velocity is and how fast you throw. Now remember, it's going to be in feet per second. You just have to do a little conversion. So you can use Google to convert it over real quick for you. But that'll tell you approximately how fast you throw. All right. Hope you enjoyed this problem and good luck. All right, for summary for this lesson, I need you to write a story and draw a picture that makes sense with the following projectile motion equation. So we have an equation there. I want you to write a story that makes sense. Okay, there's something a little tricky in this one. I want you to so you can figure it out, and then write me a little story about, like, okay, 3 to 4 sentences, about 3 to 4 sentences about this one. But I'm not going to do it for you. So again, this one I'm going to want you to do, and if you can upload it with your homework, that would be awesome too. I want to see this answer. I want to see this on your notes. All right, thank you, and hope you enjoyed.